Hello and welcome all on Unacademy JEE English. Yes, guys, Unacademy JEE English, a channel launched by Unacademy where each and every topic for IIT JEE will be taught you in pure English. And I'm Rahul Kaushik, guys. Today I'm going to take lecture number 2 of redox reaction and balancing. Right? So basically, in lecture 1, we did oxidation state calculation. That was very important because many students are confused what is oxidation state and how to calculate oxidation state or oxidation numbers. So we have already done calculation of oxidation state in the previous class, guys, and calculation of oxidation state was done through formula and then through structures. And I told you that every time it is not necessary that you are going to get the right answer using the formula. Yes. So, but if you are doing it through the structure, then guys, you will be getting 100% right answer. Right? Hi Rohit, hi Alish, hi Rohit Kumar Singh. Good afternoon. हम नहीं पढ़ेंगे. जय हिंद. Yes, Rohit Kumar. Why will you not study? Yes, tell me. Why will you not study, Rohit? Yes. Hi Roshan. I'm fine. How are you guys? How are you? Yes, just tell me. Hi Alish Shani. Hi Amy. Okay guys, I could not see your messages. Actually it was hanged and I did not know. So guys, today we are going to start this topic and I hope you guys are really going to enjoy it because today I will teach you how to balance a chemical reaction and how to balance a chemical reaction, because in mole concept we were balancing the chemical reaction by hit and trial method. Today, sir, which will be your next chapter? After this I'm planning to take chemical bonding. After this I'm planning to take chemical bonding, right? Okay. So guys, yes, is there any other query? Yes, honey. Are you the fan of Honey Singh? Okay, Alicia Shani. So guys, today we are going to discuss balancing, and I personally think that after today's class you will not face any issue in balancing redox reaction in your life. Right guys? Right? So be focused on this guys. But before I start today's session, let me tell you something about myself. Yes guys, I'm Rahul Kaushik. I worked in Bansa classes quota for continuous 10 years, guys. I worked in Bansa classes quota for continuous 10 years and I was head of department there. And during my tenure there, I mentored 2000 plus IITians, guys. Yes, 2000 plus IITians. And after that, I co-founded my own organization, that is Jnana Education Private Limited. And now I'm here on Unacademy, India's largest and fastest growing online platform, to share all my experience and knowledge with you guys. So guys, I hope you guys are really enjoying these sessions and many of you have learned many things. Guys, as usual, I generally say you should always have a copy and pen with you whenever you are starting my lecture. Whenever you are studying, guys, without copy and pen, it would be wastage of your time. Okay guys, so get ready for it. Get ready for it guys. Now let me tell you how you can subscribe to Unacademy. So guys, there are some simple steps. Step number 1, yes, just step number 1, just install Unacademy learning app. Download it using your app store or play store. Once you have installed it guys, you will be directed to this page, and on this page you have to click on the plus. Once you are clicking on the plus, you will get these options. So you have to choose IIT JEE because we are preparing for it, and then hit the subscription button. Okay guys, so once you are hitting the subscription button guys, then I have some important information to tell you guys. Yes, that's very important. Just a minute. Yes. And what is that information guys? Yes, it is breaking news for you, and I'm leaking it for last 2 days. This news is getting leaked. So guys, from 10th of September there is price hike, right? Hi Ravish, good afternoon. So after 10th of September, there would be a price hike, guys. And don't forget this code Rahul game, because if you are planning to subscribe to an academy, then this is the right time, guys. So currently, if you are applying my code Rahul game, you just have to pay 27,000 for 1 year and 32,000 for 2 years, right, guys? And after the fee hike, instead of 27,000 you have to pay 34,000, and instead of 32,000 you have to pay 50,000. Yes guys, any doubt please ask. So guys, this is the right time, and apply my code Rahul Cam and you will be getting this, right? So currently you just have to pay 2,500 per month or 1,500 rupees per month if you are going for 1 year or 2 year program. And if you are applying my code Rahul Game, you will be getting flat 10% off. Right, guys? And what are the advantages of this Unacademy's Plus program, guys? Hi Vinay, hi Vinay. So guys, every fourth class would be doubt clearing session. There would be weekly sessions. There would be weekly sessions or weekly quizzes, and there are regular tests. And guys, once you are part of subscription plan, you will get access to not just my video lectures but the video lectures and content of all the educators who are teaching there. Yes, Bhupati ji. Hi, I am Harish. Yes, I've seen you after so many days. Yes, Bhupati, I've seen you after so many days. Hello Monica, hello Roshan, hello everyone. So guys, are you ready for today's session? And that session is going to be very interesting, and I personally think you guys are going to enjoy it. And after this, in your life, you will never face issues in solving redox balancing, especially redox balancing. But for those who have not attended my previous lecture, lecture number 1, because today I'm going to take lecture number 2. So guys, just revise lecture number 1. Even if you have not revised and you don't know anything about lecture number 1, then you can do that after today's class, right? So just revise lecture number 1. That is very, very important. Okay, guys. Okay, Harish. So, guys, get ready for it. Redox and equivalent concept. So, the balancing of redox. Now we have how to balance a redox reaction. Guys, you should have copy and pen with you. Then we have lecture number 2. So, guys, and yesterday's class, this chapter is redox and equivalent concept. NCRT, I think with chapter number 7 or 8. Okay. So guys, what is redox reaction? What is redox reaction? In last class, I told you what is oxidation number, what is oxidation number, and how to calculate oxidation number. You did this calculation by some rules, and then you used some formula, and then you use some structures. Right, guys? Right? So, what is redox? Actually, if I talk about redox, it is sum of two words, red ox. So guys, this RED for reduction and this OX for oxidation, right? Yes, this is for reduction. This is for oxidation. Yes, any doubt, guys? Please tell me. No doubt. Okay. So guys, now I'm moving with the redox reaction. So an oxidation reduction reaction is one in which oxidation state of reactant change. Actually, the first point is, guys, how will you identify a redox reaction? How will you identify that redox reaction? Yes, can anybody tell me? You will identify a redox reaction by finding oxidation state. And if oxidation states are changing, then you will say this is redox reaction, otherwise this is non-redox reaction. So in this universe, every redox reaction consists of two parts. One part is called oxidation half, another part is called reduction half. Actually, only oxidation half or only reduction half is not possible, right? So the oxidation half and reduction half both, so the oxidation half and reduction half both are possible only simultaneously. Only oxidation half or only reduction half are not possible. Yes, tell me. Tell me, guys. No, it is 11th class chapter. Roshan, it is 11th class NCRT. So now I will discuss. Like, guys, uh, suppose I'm writing here CaCO3, and on heating it gives you CaO plus CO2, right? If I calculate the oxidation state for Ca2 plus, I know it is plus 2. For carbon, if you calculate plus 4 and it is minus 2. Here it is plus 2 minus 2 plus 4 minus 2. Yes, I told you in previous class how to calculate oxidation state. So guys, in this case, oxidation of each element is same. Oxidation state is not changing, right? It is not changing at all. So I will call this reaction as non-redox, right? I hope you got it. I will call it as non-redox. Then what is redox? Then what is redox? So guys, now I am going to take zinc plus Cu2 plus Zn2 plus and Cu solid. And here if you will take, zinc is getting converted into Zn2 plus, Cu2 plus is getting converted into Cu. Right guys? Here oxidation state of zinc is 0, oxidation state of copper is plus 2, and here it is plus 2, here it is 0. So you can see copper is going from plus 2 to 0 and zinc is going from 0 to plus 2. Right guys? So if oxidation state is changing, then you will call it a redox reaction. Okay guys, then you will call it a redox reaction. Yes, tell me if you have any doubt. Any doubt guys, please ask. No doubts? So now you know what is redox. So redox consists of two parts. One is oxidation half, another is oxidation reduction half. And only oxidation half or only reduction half is not possible. Oxidation will take place only when reduction is taking place. Right guys? Note it down. So guys, this was classical or old criteria. This is old criteria. What is oxidation half? What is reduction half? So guys, just 100 years back, scientists used to call addition of oxygen is oxidation. So okay, Vinay, I will look at it if there is any issue because I generally upload them before the class. Maybe they are going in somewhere else. So guys, this is addition of oxygen, and I'm intentionally telling you the old criteria. Then I will come to the modern definition. Addition of oxygen is called oxidation. And what are the examples? What are the examples? Now let me tell you. C plus O2 will give you CO2. S plus O2 will give you SO2. So guys, these are the examples of oxidation. Now what is reduction? So loss of, like if I'm writing CO giving you CO plus half O2, SO3 giving you SO2 plus half O2. So guys, this is reduction. So addition of oxygen is called oxidation, and removal of oxygen. Here we have two oxygen. Removal of oxygen is called reduction. Right guys? Now I'm talking about in terms of hydrogen. Removal of hydrogen, it is C2H6 and it will give you C2H4 plus H2. Yes, guys, this is just 100 years back. This is classical definition. I should call it classical. Yes. Do you understand the classical music? Classical means the old music, and then we have hip hop and modern. So I will come to the modern definition as well. But I have to tell you the classical. Actually, finally, I will tell you there is no difference between classical and modern, but you should know about this thing. So removal of hydrogen is called reduction, and addition of hydrogen is called reduction. Removal of hydrogen is called oxidation, and addition will be called. So again here you can write C2H2 plus H2. So these are examples of reduction, right? And this is example of oxidation, removal of hydrogen. Yes, Vedant, it is basic 7th generation iPad, right? I have to answer these questions as well. So yes. So now I'm moving increase in oxidation state, guys. So increase means if Zn is going into Zn2 plus, and it will occur only after losing 2 electrons. So here oxidation state was 0, here it is 2. So this is called oxidation. And what is reduction? If you are reducing it, copper solid. Now guys, you can write here oxidation state is plus 2, but here we have it 0. So it is going from plus 2 to 0. So it would be reduction. So increase in oxidation is called oxidation, and decrease in oxidation is called reduction. So guys, loss of electron, again it is same point. Loss of electron is oxidation, and here we have gain of electron, right? Hey Vedi, who are you guys? So guys, just note it down. Just note it down. And now give me the answer. Now give me the answer. Like tell me if Cl minus going to Cl2. Yes. So there is one minus. What is this? Oxidation or reduction? Tell me guys. Write in the comment box. I'm waiting. Cl minus going into Cl2. Be fast guys. Is it oxidation or reduction? Chinnu says it is oxidation, and what others are saying, guys? Oxidation. Very good. So guys, here you can see we have one chloride and here we have two chlorine. So write down 2 here, and then you will lose 2 electrons. So there is loss of 2 electrons here, right? And loss of electron is called oxidation. And there is one more thing here, oxidation state is -1 and here it is 0. So which one is more? 0 is more, -1 is less. So whenever you are losing the electron, then oxidation state will increase. Okay guys, so now tell me if I'm writing CuO and it is getting converted into Cu2O, right? So yes, tell me, is there oxidation of copper or reduction? Be fast. Be fast. Everybody. So just calculate the oxidation state here. Okay, me. So if you are calculating oxidation state here, it is +2 and here it is +1. So it is going from +2 to +1. So again there will be gain of electron. So guys, it is case of reduction. It is case of reduction, right? So guys, note it down. Note it down. Only oxidation half or only reduction half is not possible. Oxidation and reduction can occur simultaneously. Note it down. Only oxidation half or only reduction half are not possible. These can occur simultaneously only, right? Note it down, guys. So in this world there is no reaction that is only oxidation half. Oxidation will only take place if reduction is taking place. Hello Rohit. So guys, this is the modern definition. Modern definition. So what is this modern definition? What does it tell you? It says oxidation is the process in which some element oxidation state of element increases. And how will it increase? So let me tell you, if it is A, it is giving you 2 electrons. So I will write 2 plus. So in general I can write A n plus and it will give you n electron. Right guys? So guys, this is called oxidation. So what is oxidation, guys? Oxidation is basically loss of electron. Yes, modern definition only explain oxidation or reduction only by electrons. Hi Manjul. Hi Manjul. In KO2, I took this case nomen last time. This is superoxide. Yes. Have you done it? So guys, what is reduction? Reduction is a process in which oxidation of some element decreases. And how will it decrease, guys? How will it decrease? Now you can again write An plus n electron will give you A, right? If I'm writing A2 plus 2 electron, so here we have 2 plus and here we have 2 electron, 2 minus, so it would be A. So this is example of reduction. So in reduction, oxidation is going from +2 to 0. So oxidation number will decrease. Note it down. In reduction, oxidation number will decrease. Note it down, guys. Note it down. Be fast. I can't see your likes, guys. Yes, I can't see your likes. If you are understanding it, then those should appear in form of likes. So guys, have you done it? So now oxidation and reduction half must always occur together and the total number of electrons associated with oxidation must be equal to this. Any doubt, guys? So guys, now I will be taking a reaction. Yes, suppose I am taking Fe2 plus and I'm writing MnO4 minus and it is getting converted into Fe3 plus and Mn2 plus. Yes guys, now tell me for which element oxidation state is changed. Tell me guys. Yes, for which element oxidation state is changing? Be fast guys, be fast. Yes. Yes guys, be fast. So just find the atomic oxidation state of each and every element. So it is +2 here, it is +3. So again I can say this is oxidation, right? And what about Mn? So for Mn I can say this is +7, this is +2. So oxidation number is decreasing. So I will take this is reduction. This is reduction. right? Good afternoon, Samarjit. Good afternoon. So guys, here I can say Fe2 plus is being oxidizing to Fe3 plus, and MnO4 minus is reducing into Mn2 plus. So oxidation of Fe2 plus is taking place and reduction of MnO4 minus is taking place, right? So guys, I can write oxidation half separately and reduction half separately. So what actually is going on? What is going on? So Fe2 plus is converting into Fe3 plus and one electron. So it will lose one electron because it is going from 2 plus to 3 plus, 2 plus to 3 plus, right? Now I will move MnO4 minus. MnO4 minus will go to Mn2 plus. And what is oxidation state of Mn plus 7? And what is oxidation state of Mn plus 2? So plus 7 to plus 2 means 5 electron will be gained, because plus 7 minus 5 I have to do, so electron is having negative charge. But now the problem is, guys, yes, this is losing 1 electron and this is gaining 5 electron. So guys, from where these electrons are coming? Actually this Fe is losing the electrons and this Mn is gaining the electrons. Fe2 plus is losing the electrons and Mn is gaining them. So Mn plus will gain only when if Fe2 plus will lose, and if Fe2 plus stop losing electron, then it will stop gaining. That's why I told you that only oxidation is not possible and only reduction is not possible. And guys, Fe2 plus is giving one electron. It is giving one electron only because MnO4 minus is there. So there must be something which can absorb the electron. There must be something which can absorb the electron. Okay, guys. So because there is MnO4 minus, that's why Fe2 plus is losing, and because there is Fe2 plus, that's why it is gaining. So guys, we can say reduction of MnO4 is facilitated by Fe2 plus. So I will call Fe2 plus as reducing agent. Why? Agent are the people who works for the others. So reducing agent means it is reduce MnO4 minus, but guys, you can see it is itself oxidizing. Fe2 plus is getting converted into Fe3 plus, so I can say oxidation of Fe2 plus is taking place, and because it is losing one electron and that electron is gained by MnO4 minus, so I would say it is helping in reduction of MnO4 minus, right? And vice versa, because MnO4 minus is gaining electron, that's why Fe is losing. If there is no MnO4 minus, then Fe2 plus cannot lose. So I can also say that MnO4 minus is oxidizing agent. Why? Because it is facilitating the oxidation of Fe2 plus. If there is no MnO4 minus, there would be no reduction. So guys, now we have two terms. One is reducing agent and another is oxidizing agent. So here oxidizing agent is MnO4 minus, and this MnO4 minus is itself getting reduced, and this is reducing agent. Reducing agent is itself getting oxidized. Note it down, guys. So next point is, what is reducing agent? These are the substances which reduce others but themselves get oxidized. These are also called reductant. So I'm again writing here, right? Fe2 plus is getting converted into Fe3 plus and Mn is getting converted into Mn2 plus. Yes. So here, what is reducing agent, guys? Fe2 plus is being oxidized. So this is reducing agent. This is oxidizing agent. Note it down. So these are the substances which reduce others but themselves get oxidized. These are called reductant. So here this is reducing agent or reductant. This is oxidizing agent or oxidant. So oxidant itself will get reduced, right? Here you can see these are the substances in which oxidize others but themselves get, these are called oxidant. So what is oxidant here? This one. Here if you see MnO4 minus, it is gaining 5 electron and converting into Mn2 plus. Yes, plus 2. Tell me. Yes, guys. So I hope now you have got the idea about what is reducing agent, what is oxidizing agent, what is redox reaction, and how does it take place. Yes, tell me, guys. Hello, Samarjit and everyone. I'm not getting any answers. So are you enjoying this? So I think now you know what is oxidizing agent, what is reducing agent, right? So can you identify? Now I'm giving you one problem. Yes. Suppose I'm writing, suppose it is like this. Then find oxidizing agent and reducing agent. Yes, guys. Find it. Find it. Find oxidizing agent and reducing agent. Tell me now. Be fast. I'm getting no answers. Yes, guys. Okay, Amy. Let's see what others are saying and then I will discuss. Okay, Amy is saying iron is oxidizing agent. However, Bhupati ji is saying that NO3. So guys, let's see now. Let's see. 2 plus 3. So guys, it is oxidizing. Fe is getting oxidized. So guys, it would be reducing agent. So other would be oxidizing agent because here we have plus 5 and here we have plus 4. So this is being reduced. So oxidizing agent itself get reduced. Right. Right, Bhupati ji. Right. Got it? Yes, tell me now. So guys, just solve one more problem. Yes, tell me the oxidizing agent and reducing agent in this. Cu plus and do it. Which is oxidizing agent, which is reducing agent, guys? Now tell me. Fast, fast. Yes, guys. So copper is plus 1. Here it is plus 2. So copper is being oxidized. So guys, it will be reducing agent because oxidation of copper is taking place. Here it is plus 6. Just calculate the oxidation states. So this is being reduced, so it will be oxidizing agent. Yes. Any doubt, guys, please ask. Any doubt? No doubts? So I hope now you can find out what is oxidizing agent and what is reducing agent. Again, tell me one more problem. Cr2O7 2 minus plus C2O4 2 minus, giving you this plus this. Yes, guys, now find now. Yes, Bhupati, copper is reducing agent. Now guys, do it fast. Do it fast, guys. Tell me. Okay. Amy is giving answer, but I'm not getting answers from others. So guys, again, you just have to calculate the oxidation states. And oxidation state on chromium is +6. Here on chromium it is +3. Here on carbon oxidation state is +3. And here it is +4. So guys, carbon is moving from +3 to +4. Oxidation of carbon is taking place. So it will be reducing agent. And +6 to +3, guys, reduction is taking place. So it will be oxidizing agent. Yes, tell me. Tell me guys if you have any doubt. Any doubt. So now I'm moving ahead. I'm giving you one more question. Be fast, be fast. Sn plus HNO3 will give you SNO2 plus NO2. Do it. Do it fast. Which is oxidizing agent, which is reducing agent here? So here Sn is 0, here 4. So oxidation of tin is taking place. So it will be reducing agent. And here this is +5, this is +4. Now I can say reduction of NO is taking place. So it will be oxidizing agent. Yes, Bhupati ji, now you got the right answer. Now you got it. Now you got it. So guys, there is one more thing. Guys, there is one more thing. When I'm taking HNO3 or when I'm taking H2SO4, guys, here the oxidation state of nitrogen is +5 and here the oxidation state is +6. Okay. So here it is +5 and here it is +6. So these are maximum oxidation state because nitrogen have 5 valence electron and sulfur has 6 valence electron. So after losing all 6, it will get +6. So it cannot be more than 6. So if HNO3 or H2SO4 are present or any element is present in its maximum oxidation state, then we cannot, these two elements cannot be, can't be further oxidized. Why? Because they are already present in their maximum oxidation state. So you cannot further oxidize them, but you can reduce them. And if they are reducing, so guys, they can only act as oxidizing agent because their reduction can take place. Because their reduction can take place. So note it down, guys. So these can act as reducing agent. So guys, not just these two. If any element is present in its maximum oxidation state, in that case, it can only act as reducing agent because it is present in maximum oxidation states, right? So now let's move to the next point, guys. Yes, now I will tell you how to balance a chemical redox reaction. So suppose I'm giving you this, guys, just balance it, right? Yes, Amy, what are you asking? Oxidizing agent is something which helps others in oxidation and itself it will get reduced. Yes, you can see it here again. Here you can see this Fe2 plus is converting into Fe3 plus. So oxidation of Fe is taking place, but it is helping in reduction of Mn because electrons are lost here. That's why electrons are gained here. If it is not losing electron, then how can it gain electron? So basically this Fe itself is losing electron and getting oxidized, but it is helping in reduction of MnO4 minus. Because it is helping in reduction of MnO4 minus, that's why I'm calling it reducing agent, right? So if something is getting oxidized, then it is reducing agent. If something is getting reduced, then it is oxidizing agent. So if something is already present in maximum oxidation state, okay here. If something is present in maximum oxidation state, then you can reduce that only. And it can only act as, yes, I was wrong, it can only act as oxidizing agent. That was typo. Yes, Amy. Very good, Amy. You are very attentive. Very good, guys. So, guys, now do it. Now do it. Yes. Before I start teaching you the balancing of redox, just try this. I'm giving you 2 minutes because you might do it right, wrong, you might commit errors, and only after that I will start teaching how to move logically forward. Yes, yes, Bhupati. Now do it. Do it, guys. So, how to balance a redox reaction? What is the method? So, there are certain rules, and just note down all the rules. I will tell you the simplest way how you can balance a redox reaction. So, assign oxidation number to the element that undergoes change in oxidation number. So first, if you are given this reaction, what will you do? Just write the oxidation state of each and every element. Plus 7, 3 plus 2, right? Here you have Fe plus 2, Mn plus 7, Fe plus 3, Mn plus 2, right? So from this data, it is clear that Fe is converting from plus 2 to plus 3 and plus 7 to plus 2, right? So just write the oxidation number, and in case of oxygen it is not changing, it is in form of oxide only. So assign oxidation number to the element that undergo change in oxidation number. So I'm not assigning anything to oxygen because on the right side oxygen is not given. It means they are assuming oxygen is present only in oxide form, right? So now balance only those atoms for which oxidation number is changing, right? How will you do this? So guys, just find out Fe. So write the oxidation half separately, and you will write, and what is reduction half? What is reduction half? MnO4 minus Mn2 plus. So guys, it is moving from plus 7 to plus 2, plus 7 to plus 2. So what I'm doing is I'm simply writing the oxidation half separately and reduction half separately. You should also do it. Now what will I do? Balance only those atoms for which oxidation number is changing. Here it is changing for iron, so I am balancing only iron. Here it is changing for manganese, so I'm balancing only manganese. I'm not talking about oxygen, right? Then, so now what will I do? This is 1 electron and this is 5 electron. So guys, these are basically oxidation half and reduction half. When I will write a complete redox reaction, there should be no electron visible in that. So what you have to do is just multiply it by 5. Just multiply it by 5. And once you are multiplying it by 5, you will be getting, done. So guys, now no electron is appearing in it, and your Fe is balanced, your Mn is balanced. There is one Mn on both sides, and there are 5 Fe on both sides. Right guys? Please tell me if you still have any doubts. Hi Harshini Ashpa, hello doctor. So guys, is it done now? Now Fe is balanced, Mn is balanced, right? Now it says now balance atoms other than hydrogen and oxygen. So after Fe and Mn only oxygen is left. There are no atoms other than hydrogen and oxygen. So this step is not useful here. Now just move ahead. Now balancing of redox. Next step is, actually this step is not visible here, so don't worry. Note it down. Step number 4. First note these 3 steps down. Done. So now write down the 4th step guys. Now write down the 4th step. So you have balanced all atoms other than H and O. Here there are no atoms. Now only 2 atoms are left. 2 elements are left, hydrogen and oxygen. So write rule number 4. Write rule number 4. Now balance. Now balance hydrogen and oxygen. But whenever you are balancing hydrogen and oxygen, you have to keep in mind, 2 points. First, you should know whether it is acidic medium or basic medium. Otherwise, you can't do it. So, guys, in acidic medium, note it down. If it is given in acidic medium, what will happen? For one extra electron, for one extra atom, add one H2O on the other side and 2H plus on same side. Note it down guys, it's very important point. For one extra oxygen atom, add one H2O on the other side and 2H plus on the same side. Now how will you calculate number of oxygen atoms? So guys, here we have 4 oxygen atoms and here we have 0. So there are 4 oxygen atoms, extra 4 oxygen atoms. So what I will do now, for one extra oxygen atom, add one H2O on the other side. So for 4 extra, I will add 4 H2O. Now oxygen is balanced, but 8 hydrogen are extra, and it says 2H plus on the same side. So for 4H2, I have to add 8H plus, and now this problem is done. You can check everything is balanced, guys. Everything is balanced. 8H plus. Do it, guys. Yes. Any doubt? Tell me. Done? So this is how we are going to balance in acidic medium. Now, what about in basic medium, guys? What about in basic medium? Now note it down. Note it down. In basic medium, in basic medium, for one extra oxygen atom, add one H2O. For one extra oxygen atom, add one H2O on the same side and 2OH minus on the other side. So guys, for one extra oxygen atom, add one H2 on the same side and 2OH minus on the other side. What is this? Actually, the previous reaction can be balanced only in acidic medium. Just for understanding, I'm telling you. Actually, experimentally it is wrong, but just for understanding, guys, if you are writing it Fe2 plus and MnO4 minus, so you will be getting Mn2 plus and Fe3 plus, right? Now just count the oxygen. We have 4 oxygen extra here. So for one extra oxygen atom, add one H2 on the same side. So I'm adding 4 H2. Now there are 8 oxygen and there are 8 hydrogen. Now what will I do? E2H minus. I'm telling you this reaction does not take place in basic medium, but for understanding purpose I'm giving you. Note it down. Note it down, guys. Any doubt, please ask. Any doubt? And there is a note of caution here. What is that note? Yes. While balancing reaction, while balancing reaction, we should check that all atoms and net charge should be balanced. So guys, in a balanced reaction, you should always check total charge on both sides should be equal as well as total number of atoms on the both sides should be equal, because here if I'm calculating the total charge, right, so here I will be having plus 10 and minus 1, so the net charge is plus 9, and here it is plus 15, plus 2 and minus 8. Just add them. Again it will be plus 9. So net charge is same on both sides. Total number of atoms are balanced. Only then I will call the reaction balance. So a balanced reaction should have number of atoms as well as number of charge balanced on left side as well as on right side. Yes guys, tell me if you have any doubt, guys, tell me. No doubt. So there is one more point. There is one more point. Sometimes simply by adding water, reaction get balanced. What do you mean by it? I'm saying I just told you when I'm adding 4H2, I'm adding 8 OH. It is not necessary that every time you have to add 8 OH. Just check. Sometimes just by directly adding water, your reaction will be balanced. Just by directly adding water, your reaction will be balanced. Okay. Yes, just check it. Right, guys? So it is not like, sir, you told me every time if I'm adding one H2, I have to add 2 OH minus on that side, or if I'm adding one H2, then I have to add 2H plus. No, just check. Sometimes even just by adding H2, your reaction might get balanced, right? So guys, this is how balancing is done. And now I'm going to give you some problems over balancing, right? Just do them. Yes, just balance it in basic medium. So they might also write it as like OH minus. Note it down. Do it. Do it, guys, fast. Let me see who solves it. Amy, Dr. Harsinius, Bhupati ji, anyone. Yes, guys, do it fast. So you have to balance this redox in basic medium. Balance it. So first of all, rule number one, just write the oxidation state +7 +4 +3, and here it would be 8 by 3. 8 by 3, right? Yes. Now what will you do? Now write the oxidation half and the reduction half separately. So Mn is going from +7 to +4. So just write this reaction. Three electrons are there, right? Three electrons are there. Now what will happen now? Just check Mn is balanced. Yes, on both sides Mn is balanced, because I told you the rule number 2, balance only that atom for which oxidation state is changing. So now just write Fe3 plus, and it is going to Fe2O3. So here we have 3 and here we have 2. So I have to balance it, multiply it by 2 and multiply it by 3, right? So what is oxidation state here? Here it is +3, and here it is 8 by 3. So 8 by 3, this is the charge on single Fe, and here we have 6 Fe. So Fe 8 by 3 into 6 plus 16. So Fe is moving from +16 to 6 into 3 plus 18. So it would be +2 electron loss. Yes, guys, this point was critical, right? So here we have 3 electron, here we have 2 electron. Now I have to multiply it by 2 and multiply it by 3. So I will be getting 2 MnO4 minus and 6 Fe3O4, 9 Fe2O3, 2 MnO2, right? So guys, do it carefully, because there are maximum chances of error in this problem. Yes. So now Mn is balanced, Fe is balanced. There are 2 Mn, there are 2 Mn. There are 18 Fe, there are 18 Fe. Now I have to balance oxygen, because there is no other atom. So just count the number of oxygen atoms, guys. Just count them. Here we have 8 and 24, 32. Here we have 27 and 4, 31. So here we have 32, here we have 31. So what was the rule? In basic medium, for one extra oxygen, we add one H2O and then 2 OH. I think now problem is done, guys. Please tell me if you have any doubt. Done? Note it down. Note it down. Yes, Emily, Emmy. Bhupati ji, Harshin Yashwa, anyone? I'm not getting your answers. Please tell me why I'm not getting your answers. Tell me, guys. Okay, if this is clear, then guys, do it. Do it. Do it, guys. Balance it. Let's see who solves it. Be fast. Again, this time you have to do the balancing in acidic medium. This is also given acid. Yes, guys, do it. Do it. So, it is plus 7 plus 2. Here carbon is plus 3. Here carbon is plus 4. Now try it. Now write oxidation of separately and reduction of separately. So, plus 7 to plus 2. This is reduction. This is oxidation. Now write these reactions separately, guys. Write them separately. Yes, do it. Yes, now I have given you some hint. You can solve it now. You can solve it. Okay, Amy. Now do the easy part first. Let me see. MnO4 minus is going into Mn2 plus. 5 electron. Right? Now plus 7 to plus 2. C2O4 2 minus giving you 2CO2. First balance the carbon atom. I told you balance only those atoms for which oxidation state is changing. Here on one carbon we have 3. On one carbon we have 4. So for carbon I can say 2 carbon will have plus 6 and 2 carbon are going into plus 8. So net change will be 2 electron change. So it will be loss of 2 electron. Right, guys? And if it is loss of 2 electron, guys, just multiply by 2, just multiply by 5. Yes. So what will you get now? 2 MnO4 minus C2O4 2 minus. Done. But still oxygen is left, right? And if oxygen is left, then what would you do? Just count the oxygen atoms. Here we have 8 and here we have 20. So total we have 28, 20. So 8 oxygen are extra here and medium is acidic. So I will write 8H2O and here it would be 16H plus. So what will be the final reaction, guys? What will be the final reaction? It will be 16H plus 2 MnO4 minus 5 C2O4 2 minus. Right? So just calculate the charge now. Plus 16 minus 2 and minus 10 plus 4 plus 4. So total charge is balanced. Total number of atoms are also balanced. So now this reaction is balanced. So guys, this is the way how to solve a redox reaction by logical balancing. Because in mole concept, you guys used to solve these problems using hit and trial method. So Amy, your answer was correct. Very good, Amy, excellent. So guys, let's take another problem now. Now do it. Do it fast. Again, this H plus is showing you have to balance it in acidic medium. It is easy problem, guys. You can do it. Do it. Yes, guys, be fast. Do it, guys. I will help you out. First, you try by yourself. First, you try it. So, I am giving you some hints. Oxidation state is plus 7. Here it is plus 3. Here it is plus 4. And here it is plus 2. Now solve it. Now solve it. Do it. So plus 7 to plus 2 reduction, plus 3 to plus 4 oxidation. How will you do it, guys? So just write this one. We have 1 Mn, MnO4 minus going into Mn2 plus, plus 7, 5 electron, right? So now Mn is moving here. And what about C2O4? It is going into CO2 gas. The 2 carbon are here. So first you have to balance the carbon atom. I told you balance only those atoms for which oxidation state is changing. So here oxidation state is changing for carbon, so I am balancing the carbon. So carbon is moving from plus 6 to plus 8. Why? Here it is plus 3 and 2 carbon will have plus 6. Here it is plus 4 and 2 will have plus 8. So plus 2 electron, it will lose 2 electrons. Right? Okay, shorts guy. Why they are criticizing? So now, now what they are doing exactly? We have 2 electron here, we have 5 electron. Just cancel them. And I will be getting 2 MnO4 minus and C2O4 minus CO2 gas 2 Mn2 plus. I think now it is done. Now balance the oxygen atom. Yes, Amy, I think you have done it. Are you saying Pahul shots or the Rahul? Okay, guys. So, guys, I am telling you how to balance the chemical reaction by shortest way, quickest way, and the best way. If you are not learning, please you should have copy and pen. Try it by yourself. First, I give you the hint, then I give you the problem. So, what will you do? What are you saying? The Moses promotes his code or coupon too much for that. Okay. Okay. So guys, now here you are getting this. So how many oxygen atom are there? It is 8. It is 20. 28. Here we have 20. So again, yes. Here I was taking H2SO4. Here I am just showing H plus. So I just wanted to tell you that there is no difference in it. There is no difference in it, guys. Again, here we have 20. So write 8H2O and write 16H plus. Balancing would be same. My purpose of this reaction is to tell you that it does not make any difference whether you are taking H2SO4, whether you are taking HCl, HBr, any acid. So guys, now do this. And now this time I'm expecting everybody would write the complete answer. Yes, just like Amy is writing. Yes, guys. So I'm waiting for your answers. For 2 minutes, I will keep quiet. I will be mum. Solve it this time. And I want this answer from everyone. Then I will start. So do you guys want some hint? Yes, tell me. Do you guys want some hint? No hints. Okay, now I'm giving you the hint, guys. It is plus 6, plus 3, plus 3, plus 4. Now you can say it is reduced, it is oxidized. So write the reduction half and oxidation half separately. Yes, the shorts guy, you can also do it. You can also do it. Yes, do it. So write oxidation half and reduction half. And I'm waiting for your answer. Be fast, guys, this time. Why only Emmy is giving answer? Why not all others? Oh, Emmy, you are quite fast. So how will you do this? Yes, now let me tell you. Cr2O72 minus. So first of all, balance the chromium atom. Here we have 2, right? So the oxidation state of one chromium is plus 6. So on 2 chromium, it would be plus 12. And here it is plus 3. It is going into 6. So minus 6 electron. So it will be gain of 6 electron here. It will be gain of 6 electron. Now C2O42 minus. It is giving you CO2 gas. So the carbon here is plus 4. Sorry, plus 3. And here it is plus 4. So it is moving from plus 6 to plus 8. Plus 2 electron. Right? So now here we have 6 electrons. Here we have 2. So multiplied by 3. Electron will get cancelled out. So you will be getting Cr2O72 minus 6 CO2 gas and 2 Cr3 plus. Yes, guys, do it. And now you will be getting 12 oxygen, 19 oxygen, and acidic medium is there. So there are 19, there are 12. So I will add 7H2O and 14H plus. Now this reaction is balanced, guys. Now this is balanced. You can see. Please look at it now. Any doubt? Please ask. So why only Emmy is giving answer? Why not others? There are so many students sitting. Yes. So guys, the next problem I'm going to give you is a bit difficult because in this problem one more extra step will be required. So I will give you the sufficient time, guys. Now do it. Do it, guys. Do it fast. Do it. I will give you the hint after 60 seconds only. So for next 60 seconds, just try it yourself. Right, guys? Just do it. Yes, be fast. Oh, I'm waiting. So let me give you the hint. The oxidation state of Y minus is -1 and chromium is +6. Here I minus having 0 and it is +3. For others it is not changing. Yes, I can show you. Here chloride is -1 -1, not changing. Here Ba is +2, so it is always fixed. And anything else K plus 4K plus, it is also always fixed. So oxidation state of only chromium and iodine is changing, and here HCl is providing the acidic medium. Right, guys? Do it. Do it fast. Now I have given you the hint, and I think now you can do it. Yes, guys. So write the oxidation half and reduction half separately. +6 is going into +3. -1 is going into 0. Right? So just write this. It is +3. It is +6. So it is gaining 3 electrons. Clear? I have done half part. Now half part you guys do it. Yes, do it. I'm waiting. Yeah, guys, be fast. Be fast, guys. Yes, Amy, excellent. You have done it. Again, it was very good problem, and Amy has done it, guys. Now I will do it. So this is Ki. It is giving you I2. So from -1 to 0. So first I have to balance the iodine. So iodine is going -2 to 0. So 2 electron will be here. And just multiply it by 2 and multiply it by 3. So what you will be getting? 2BaCrO4 6Ki 3 iodine, 2 CrCl3. I think now it is clear. And now, other than H and O, you have to balance other atoms. So there is chloride here. So just balance it. So there is Ba, no Ba is there. So it is saying BaCl2. So I will write 2 BaCl2 because 2 Ba are there. Because till this point I have balanced only chromium and iodine. And there are 6K. So KCl will be 6. Now count the chloride. So there are 6 and 4, 10 and 6, 16. So I will write 16 HCl. Now chloride is balanced, but along with chloride we have 16 hydrogen and we have 8 oxygen. So I will be getting 8 H2O. Now this is balanced, guys. Now this is balanced. Yes. Yes, Amy, you were right. You were right, Amy. So guys, there is one more problem. Do it. Do it, guys. Do it fast. Do it fast. This time everybody should solve it. Yes, I'm waiting. I'm waiting, guys. I will give you a hint. So guys, now I'm giving you the hint, guys. Here it is plus 5. Here it is plus 2. And what is the difference in this problem, guys? The difference is here AS is plus 3 and sulfur is minus 2. Here AS is plus 5 and sulfur is plus 6. So AS as well as sulfur, two atoms in one compound are getting oxidized. Up to this point, only one atom was getting oxidized. But now two atoms are getting oxidized. So what I have to do now? What I have to do now, guys? Yes, do it. Do it, guys. Now you know the difference. Plus 3 going into plus 5, minus 2 going into plus 6. So guys, there are two elements that are getting oxidized. Up to this point, there was only one element. Yes, Amy, all this time. It's a bit difficult. It's a bit difficult. So do the easy part first. Plus 5 to plus 2. So 3 electrons are being absorbed. It's tough. Yes, I know I have to increase the level, guys. So after this, you have to write As2O3, As2S3. It will give you. Now 2As is there. And then we have 3H2SO4. Right? So just write what is change in As. So here it is plus 3. Here it is minus 2. So there are 2. 6. And here it is plus 5. So plus 6 to going into plus 10. Plus 4 electron. And what about sulfur? Sulfur, there are 3 sulfur. There are 3 sulfur and one sulfur is having minus 2. So 3 sulfur will be having minus 6. So sulfur minus 6. And here it is plus 6. Minus 6 to plus 6. and there are 3, so it would be plus 18, so 24 electrons. So total electron would be 28 electrons, right? So 28 electrons are lost, 3 electrons are gained, so multiplied by 28 multiplied by 3, right? So 28 HNO3 will give you 6, 9 and 28 NO. Now I think this is clear. This is clear now. Is it balance or not? Just count nitrogen, AS and this. These are balanced. Now just count oxygen and hydrogen. So guys, there are 84 oxygen, and just count here. Yes. How many oxygen atoms are there? Tell me guys. How many oxygen atoms are there? 88. And here we have 84. Now what should I do guys? What should I do? This HNO3 is acidic. This HNO3 is acidic. Yes, tell me guys. What I should do now? Add water. On which side? For one extra oxygen atom, add one H2O on the other side. Right? One H2O on the other side. So on which side I have to add water? For water. But now hydrogens would be extra. Now count the hydrogen. 36. And here we have 28. So I need 8 hydrogens here. Now everything is balanced. Once you are adding 4 H2 on the left side, everything would be balanced. Right? So guys, this is all about balancing. Tomorrow I will take some more problems on balancing, but those problems would be tough. So guys, get ready for next class. And after balancing, then we will move ahead. What is law of chemical equivalence, and why do we need such a law? What is the importance of that law? So everything would be done. Everything would be covered in the next class. Okay guys, this is all for today guys. This is all for today. And guys, if you have really liked today's lecture, guys, then don't forget to share it and like it, and click on the bell icon so that guys you can get latest notification of our lectures. And right, if you want to subscribe Unacademy guys, once you have installed it, then click on the plus, and after clicking on the plus you will be getting IIT JEE and NEET UG. So once you are getting IIT JEE and NEET UG, then hit the subscription button. Once you are hitting the subscription button guys, you will be getting these options. So this is important piece of information I have to give you guys. And before 10th September, if you are applying, it would be better for plus course, because guys, on 10th September there is price hike in all courses, and the difference in the price hike would be guys, right now for 1 year you have to pay 27,000, but after 10th September you have to pay 34,000, even after applying my code Rahul Kaushik. Don't forget this code. And for 2 year course, currently you have to pay 32,000, but for 2 year in that case you have to pay 50,000. So guys, don't delay. do it now, right? So guys, this is all. And what you people are going to get, you people are going to get structured course where every fourth class, count class, there would be weekly quizzes, everything would be there, guys, right? And if you are applying this code, don't forget it, this code Rahul Game, you will be getting flat 10% off, right guys? So today I told you, I taught you how to balance a chemical reaction. And initially we took simple problems and then gradually we increased the level. In the next class as well, I will be taking some balancing problems and then I will proceed ahead. And guys, get ready for the next class. And this is for now. Today's session is over, and I will meet you again in the next class, guys. Take care of you.